Hey guys, so the first part of this lesson is a warm-up reviewing Algebra 2 and rules of exponents. So the first one, which we've gone over before, is that if you multiply two exponentials with the same base a, then their exponents are going to be added. So how does that apply to the problem on the right? You have two exponents with the same base, therefore you can add their exponents, and you don't need parentheses because it's addition. And if you simplify that out, you get 5 to the negative 2x, 2x minus 4x, and negative 3 plus 5 plus 2. So this would be written as a single base. The next rule would be division, meaning if you have the same base, you can subtract exponents. So on the right side, the issue is we have a lot going on. So yeah, we have a fraction, but we also have multiplication in the top and the bottom. So first, we're going to apply Rule 1 to the top and the bottom. So adding the exponents on top would look like this. And if you want to go straight to it, that's 2 to the 4x plus 4. And on the bottom, when you add your exponents, 2x plus x is 3x. And 1 minus 5 is negative 4. Now that you've combined the numerators and denominators separately, we can apply this division rule, which says if you have the same base, 2 and 2, you can subtract exponents. Now what I would do is, unless you're doing it in your head, make sure you are subtracting the entire quantity. You do need parentheses for subtraction, because then it's minus 3x minus negative 4. So that will give us 2 to the power of 4x plus 4 minus 3x plus 4. And then combining like terms, we get 2 to the x, and then 4 plus 4 is 8. Number 3 is a power to a power. When you have power to power, you multiply. A to the m times n. So the power to power is this one right here. We're going to multiply 3 times x and 3 times negative 2. So then you get 2 to the 3x minus 6 times 2 to the 2 minus 2x. And then from there, you add exponents because it's multiplication. And that's what you should end up with. Okay, moving on, and again, you can be pausing the video and trying these on your own. We have a to the negative n, and we already went over this in class. That's 1 over a to the positive n. So the issue here is I have two pieces. To write it as a single log, we're actually first going to write this one as two separate logs. So remember, addition means that originally you had 3 to the negative 2x times 3 to the second. Now we'll apply our rule of negative exponents, and we'll move the term with the negative exponent to the bottom. So this becomes 3 to the second over 3 to the positive 2x. Can't really write this one as a single log. The only thing we can do is simplify the top and leave the bottom alone. The next one states the rule that a to the 0 and a to the 0 is 1. Anything to the 0 is 1. So again, you should be pausing the video and trying these on your own, but when you're done, there is one important thing here that stops you from being able to combine. So think about what that is, and you'll notice this base is different than this base, and therefore addition rules do not apply. So how do we fix that issue? To fix that issue, you can rewrite 4 as 2 squared. That way, you have all the same base. And the new exponent is 2 times 2x plus 2. You just want to put whatever was in the exponent in parentheses when you do this. And then you have the rest. And now you can go ahead and distribute and apply your rules. I'm going to pause the video and get straight to the answer. That way you can just start checking now. So your answer should have been 1. You should have ended up with the same exponent on top and bottom. And when you subtracted them, you got 0. And 2 to the 0 is 1. The next one, you have the same situation, but first let's talk about a to the m divided by n. Fractional exponents mean roots. Now, the root is always going to be the nth root. So if that's 2, it's a square root. 3, cube root. 4, fourth root. The m is going to be whatever the exponent is, and you can write it on the inside, or you can write it on the outside. Doesn't matter. And the base goes inside. So here we have a lot going on inside, and again, we have an issue where your bases aren't the same. See if you can change the base on your own, and then continue the video. So you should be getting that in order to make these the same, 9 can be rewritten as 3 squared, and then the exponent left is x minus 4. Now, because it's multiplication, you can go ahead and add these together. So again, pause the video and simplify it yourself. All right, so the last step from here is using this rule, which says, since it's a square root, 2 is your index, and I can rewrite this as 3 to the power of 4x minus 6 divided by the root. And that simplifies to 3 to the power of 2x minus 3. All right, so you should be trying A on your own before even looking at this answer. When you're done, you can check it. So that was all review. I know it was long, but that's going to be super important for the next part and the next few days. So today's lesson is actually on how do you solve exponential equations with a common base. So here in the first problem, you have an example. 3 to the 2x minus 1 equals 81. Is 3 and 81 the same base? No. So you want to first rewrite the powers using the same base. So either you're going to have to rewrite 3 as 81 or 81 as 3. You can't go up. You have to go down. So we want to try to write 81 as a 3. So to do that, you're going to ask yourself, 3 to what power is 81? And that would be 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's to the 4th. Once you get the same base, it's easy from there. You get to cross off the bases, and you have a linear equation of just exponents. And then you can solve for x. So you get x equals 5/2. They get a little trickier, just more condensing. So you always want to make sure you only have one base term on the left and one base term on the right. Here you have 2 on the left, 1 on the right, and they are all different bases. So step 1, rewrite 4, 16, and 64 having the same base. Ask yourself if the smallest number can be rewritten for 16 and 64. And it can. 4 squared is 16, and 4 to the 3rd is 64. Try rewriting this on your own, see what you can do on your own, and then I'll continue the problem with you. So this should have been your rewritten form, all 4s, 4 squared, 4 to the 3rd, 4 to the x. And now you can apply your rules. So if you have the same base and things are multiplied, you can add this exponent with this exponent. So that's 4 to the x plus 6x, if you distribute that 2, minus 2. And on the right, we're actually going to rewrite it so it's not a fraction anymore. And we know we can just make that power negative. And then this becomes 4 to the 7x minus 2 equals 4 to the negative 3rd. And now that you have the same base, cancel, cancel, solve a linear equation. X should equal -1/7. in number 3. If you want to try it on your own now, you can. There will be other problems to try. Here, you have 4 and 8. Can you rewrite 8 as 4 to a power? And the answer to that is no. 4 to the power of 1 is 4. 4 squared is 16. It skips 8. So therefore, you have to rewrite 4 and rewrite 8. Think about it yourself. Try rewriting them on your own to be the same base, and then play the video. So you should have been able to rewrite 4 as 2 squared and 8 as 2 to the third, and then the bases would cancel, and again, you have an equation you can solve. Go ahead and try the next problem on your own. Go ahead and check your answer. Key thing here was you had a fraction. Once you created the same bases, you were able to subtract top numerator minus bottom. Then once you have that done, you can cancel out all of your bases. Okay, so this is just a little extension that you can do in your calculator. And if you take AP Calculus, you might have to find out what x equals when you have numbers that you can't create as same bases or combine. 5 and 2, not the same base, both prime numbers, cannot be rewritten. Therefore, you will plug in the left side to y1 on your calculator and the right side to y2 on the calculator. Once you do that, and I'll show you on the calculator, you're going to find the intersection using second calc 5. Those are the buttons you're going to click. So I will show you with this first example, and you can try the next two. So you'll type in your functions into y1 and y2. Once you do that, again, it's the left side and the right side, y1, y2. You're going to hit you're going to hit graph. You're going to look at the intersection point first. It's right here. But you're going to apply the calculating the intersection, which means you're going to hit second, trace, 5 is intersect, and it's going to ask you where's the left bound. You're going to move your cursor to the left of the intersection point and then to the right. So the left would be right there, enter, and then it will ask you for the right bound to the right of the intersection, enter. So your intersection is written on the top, 1.3, that's an eraser, 1.3, comma 2.5, 1.3, comma 2.5. So if you're solving for x, you're not going to give me a coordinate, you're just going to tell me it's x equals 1.33. And let's go back. You'll just write your answer down for that. So you guys can try the next two. They're calculator problems, and I'll circle the answers so you know what they are. So your two answers should have been B and B. That looks like B and C, but that's also B. And that's it for today.